Both binomial and geometric probabilities will require that a situation be a Bernoulli setting. Events must be categorized into two complementary outcomes, success or failure. If rolling a die, if a 6 is a success, then all the other numbers constitute a failure. Nothing else can happen, thus complementary. Each trial or random selection must be independent of other selections. This means it doesn't matter if a 6 was just rolled, the probability of a success and the probability of a failure will remain constant. So here's what it means to be Bernoulli. Trials must be independent of each other, outcomes must fall into one of two categories, success or failure, and those outcomes must be complementary. Probabilities never change from trial to trial, and those probabilities are represented as p for success and 1 minus p for failure. So what's not Bernoulli? Well, if we have 20 marbles and 8 are blue, let's find the probability of randomly selecting two different marbles and having both be blue. We declare blue as success, but by sampling without replacement, the probability of selecting a blue the second time drops to 7/19. These are dependent events, not independent. The probabilities are thus changing, and therefore that is not Bernoulli. We could make the problem Bernoulli by replacing the marble each time and then randomly selecting anew. This preserves the probability of 8/20 every time we select. A situation that is technically not independent but is practically independent so that we can treat it as Bernoulli is when sampling without replacement from a very large population. For example, suppose that 40% of Americans own a dog. If we select two different Americans, find the probability that the first one owns a dog and the second one does not. The probability of success is 0.4, the probability of failure is 0.6. Since there's more than 300 million Americans, choosing one without replacement is not going to significantly change the 40% success rate or the 60% failure rate. Thus, when selecting from a very large population, we can treat it as a Bernoulli setting.